Hey guys. The most difficult part of the Baliscissors to make is the blades. Ideally, they are laser cut, then ground, then machined, then heat treated, then machined again, then cleaned up, and then sharpened. In my last video, I removed most of those steps. I used pre-ground rectangles of A2 steel, and I didn't even heat treat it. This allowed me to quickly test a bunch of scissors, but now I need to start adding the other steps like heat treating back in. When I've heat treated in the past, I've had a lot of discoloration on my blades. I wrapped the blades in stainless foil, but oxygen still leaked in. MachineWise suggested that I use pre-made laser welded bags. I heard it was a good idea to put baby powder on your blades to keep them from sticking to the bag. Baby powder used to be talc, but it was changed due to health concerns. Now it's cornstarch based. People suggested I put a piece of paper in the bags that would burn up all of the oxygen, so I thought maybe it would be a good idea if the baby powder is something flammable. Well, it burnt so much that it blew open all the folds on one of the pouches, and it inflated the other. I'm not surprised, but at least now I know. Real talk, and the laser sealed bags does work good though. What doesn't work is how I quench the blades. I've been using air-cooled steels, which means you suck the heat out of the blades with a more thermally conductive metal like aluminum. I've just been stacking a bunch of blocks on top of each other. Hopefully more pressure means flatter blades. For a while, I wanted to replicate Grimsmo's setup with water-cooled quench plates in an Arbor Press. The problem with an Arbor Press is the pressure is dependent on how consistently you can pull on the lever. It would also be a more involved project to make. I wanted to do something quicker. Some people use vices for quenching. By turning a screw to apply the force, you can more consistently apply the same amount of pressure. The problem with a vice is you have to mount it sideways if you don't want to fight gravity. It seemed like it could be awkward to set up. I found an old forum post about using a book press. This idea really interested me, so I gave it a try. All I did was drill some holes in the top plate and tap some holes in a block of aluminum. Now it's time to quench. Perhaps an Arbor Press or some vices could be closed faster. Initially, I didn't clamp very hard. It still seemed to work well though. The heat seems to get sucked out in only a few seconds, and the plates themselves don't seem to warm up much at all. The clamping didn't take out much bend though. In later tests, I applied more pressure with the press, and it seemed to make flatter blades. But I'd still often end up with a couple thou of bend for some reason. The top of this press is actually just a U-shaped piece of steel, so when I really clamp down, I could see it start to bend. Maybe I can find an even better solution, but I still think this is a huge improvement over what I was doing. After tempering and unwrapping my blades, I found another problem though. My pinholes shrank. I decided to try to fix the problem, which means hard milling with a 1/16 of an inch end mill. Somehow, this wasn't difficult at all. I kept the cut width to no more than 2 thou, and I had a 1/2 thou chip per tooth. You can see I'm using a bigger clamp to hold down the part. I was having vibration issues with the old one. I even had a blade bend, and another blade got a bite taken out of it. I think the end mill hitting the far edge is putting a lot of leverage on the blade. So I made a clamp that holds more of the blade, and I decided to try slotting through. I hoped staying closer to the clamp would make less vibration and it'd be less likely to move. I didn't break through though, because I didn't want to mess up the fixture where I'm clamping down. It was an improvement, but I still wasn't very happy with this fixture. Then I realized what I had done. I tabbed off the tab. If I use a smaller end mill and keep the screw in, I might not need a clamp at all. I could just fit a 3/32 end mill. I went down in 3 thou steps. I had been trying to design better blade fixtures, and this made it even easier. I could go from 5 operations to 2. The Op 1 pallet is just a bunch of holes. I still made my own clamps though. I don't want to introduce bend with pit bull clamps. Another advantage over pit bulls is by turning 2 screws, I hold down 2 parts. Pit bulls would be 2 screws for 1 part. This new fixture fixed all the problems I was complaining about in the last episode. Now I can fit 8 parts instead of 6, and I have less tool changes, and I only need 1 program. I noticed that when hard milling the pinholes, they weren't cutting the same amount on all sides, which means my holes warped. So I'll just leave the holes undersized, and then always hard mill them perfect after heat treat. The fixture for Op 2 is very simple. I'm holding and locating with precision shoulder screws. I went up a size, so I don't have to use as small of Allen wrench. Now I have 2 tabs instead of 1. This means less screws per part, and I don't have to use different drivers for different screws. Last time cutting blades, extra pieces of material was left over, which could cause a crash. I added extra passes to eliminate this risk. 8 blades is a tight fit though. I had to sketch custom toolpaths to keep the tool from plunging into the other pieces of stock. Now I said it's only 2 ops, but it's really 3. If I had laser cut lengths, and I modify the first pallet slightly, I could skip the last step and go straight to heat treat, which is what I do next. Now I can clamp them back down and hard mill them. Because of the 2 tabs, nothing is in the way of me working on the pinholes. Then I can rough the bevel. For finishing the bevel, I set up a second identical tool. Hopefully, by not doing the roughing, this tool will stay sharper for the final finish. Finally, I can cut off the tabs. I left myself more room so I can go up to an 1/8 inch end mill. This worked great. I can easily snap them off. I have to clean the tabs still, but I don't think it gets much better than this. At this point, I thought I had it all figured out. All my fixtures were perfect to start mass producing Baliscissors. So I ran 8 blades at once. But my oven rack can only hold 4. I had also never done more than 2 at a time and was nervous. Here's the problem. My locating holes warped just like my pinhole. And I think I was losing positional accuracy too. I guess I just got lucky at first. It's hard to be perfect in both size and position. I should have realized. In the past, I've had to modify round locating pins into diamond pins for me to be able to mount parts or fixtures. But I can't do that here. So I added some dowel pin holes to the fixture. For some reason, I had less issues with the bottom hole on the blades. So I could get myself in the right position, and then I control the rotation by butting against a dowel pin. Then I can use a normal screw to hold everything in place. Then I remove the dowel pin. This works, but it still feels less accurate and rigid. It'd be nice to use my original plan. I thought it might help if I had more material around the hole. So I cut some blades out. Now there's 115 thou around the hole instead of 75. And after heat treat, it seemed like a possible improvement, but one hole still came out small. So there's yet another mystery to solve. It could be the steel, it could be how I heat treat it. I don't think it's the quenching pressure. Different pressure didn't seem to cause different hole sizes. The fixture works, it's just disappointing when things don't work out exactly how you expect. But then I step back and I realize how big of jumps in quality and speed I've made. I think I can stick with these fixtures for a while. Thanks for watching. See ya.